Did I? Okay, I don't know what happened there either. Okay, so we know that anything multiplied by 1 is the same answer. And so we also know that if we have 5 divided by 5, well, 5 divided by 5 is 1. So anything divided by the same number is 1. We also know more advanced stuff, such as log 2. What's that answer? Well, that's also 1. Okay, now that's something different, but that's a little trick that we learned in the logarithm kind of section. So what we're going to do here is we're going to multiply it by 1, and so the answer is still going to be 5 over root 3. Now that didn't help us at all. Multiplying by 1 it didn't change the question at all. But what happens if I multiply by 1, but instead of multiplying by a regular 1, I do this. Watch this. Okay? Now 1 is the same thing as 5 over 5, or 6 over 6, or root 3 over root 3. That's 1, right? Root 3 doesn't matter what it is. The same number over itself is 1. And so did I change the question? No. But when I multiply 1 with a fraction on, or the square root on the bottom, it does do something different. Okay? So it allows us to get the square root out of the bottom. Because the square root of 3 times the square root of 3, we can do that on our calculator, but a square and a square unsquare things. The opposite of two squares is a normal number. So square root of 3 times square root of 3 is just regular 3, always. Square root of 5 times square root of 5, the squares cancel each other out, and you get regular 5. Okay? And the top, we already know from last Thursday's class how to multiply a regular number with no square root with a square root. This is simply going to be numbers with numbers, roots with roots. Well, there's only one number. The other one's 5. It was 1, right? So it'd be 5, and no square root. And root, well, if you want, it's square root of 1, but it doesn't really exist. So it's just going to be 5 root 3. So if you want to rationalize the denominator, if you want to get rid of the square root in the bottom, this thing, all you do is you multiply by root 3 over root 3. And that's your final answer. Okay, so now the square root's not in the bottom. We follow, hey, Jeff's rule number 2, whatever that is. Okay, there's no square root in the bottom. That's your final answer. Now it looks kind of a little bit weirder, but that's all you're looking at. So let me give you another example. Let's say I'm just going to make this one up. 6 over root 2. What would you multiply by? Root 2 over root 2. And so you just go root 2 over root 2. We're multiplying it by 1. Well, what's a root 2 times root 2? Regular 2. What's a 6 times root 2? 6 root 2. There's my final answer. That's the improper format. There's the rationalized denominator format. This is the correct format, no square root in the bottom. So we're following Jeff's rule number 2, if you want. Okay? Now that's not only my rule, of course, but okay. And it's as simple as that. Let's try to make it a little bit more difficult then. Let's try 5 over 2 root 3. Well, what do I multiply there? Well, whatever's on the bottom. 2 root 3 on the bottom and 2 root 3 on the top. So then how do you multiply that out? Well, numbers with numbers and roots with roots. So 2 times 2 is 4 on the bottom. Root 3 times root 3 is 3 on the bottom. And on the top, numbers with numbers and roots with roots. 5 times 2 is 10. Nothing with root 3 is root 3. And I'm almost done. Okay? So it'd be 10 over 12 with a root 3 on the top. And again, I'm not quite simplified. Why? 10 over 12 can be reduced. Now, you don't. If you get this far, you've got. You're doing it all. Like we didn't use the calculator at all. If you get this far, we should know that when you finally get down to an answer, just use your calculator and math enter. 10 divided by 12, math enter, and it'll say, oh, it's 5 over 6. So it's 5 root 3 over 6. That's my final answer. Let the calculator will not do any square roots for you. It will not simplify square roots, but if they're regular numbers, it'll simplify everything nicely for us. So I put 10 on the top and 12 on them. I just used the numbers, not the roots, and it simplified 5 over 6. So I divided 10 by 2, divided 12 by 2. So 10 divided by 2 is 5, 12 divided by 2 is 6. But I let the calculator do that. I just put in the number, not the roots, the numbers. 10 over 12, math, enter. Done.
Sorry, I mean like 12 on the bottom from the past.
All right, so 2 times 2 is 4. Root 3 times root 3 is 3. 4 times 3 is 12. Yep. Let me dream up another number. So, what do we got? Here. Oh, root 3. Let's flip it around here. I'm trying to make it more difficult than, you know, like they're not any more difficult than this. Root 3 on the top, 2 root 6 on the bottom. Is that permissible? No. Why not? Square root in the bottom. Rule, violates rule number 2. Okay. So what do I multiply by? Well, you multiply by the denominator. 2 on the bottom and 2. There we go. 2 root 6. 2 root 6. There's your 1. I'm not changing the question at all because I'm just multiplying by 1. That's allowed. And then now I do numbers with numbers, roots with roots. It's algebra. So the number in front here is 1. 1 times 2 is 2. Root 3 times root 6. This is a little bit more difficult. What's root 3 times root 6? 6 times 3, 18. Okay. 2 times 2 is 4. Root 6 times root 6, regular 6. So on the bottom, I'm going to have 24, right? And on the top, I'm going to have 2. Does that simplify? Let's see here. 2 divided by 24. Math, enter. Yes, 1 over 12. Okay, so it's going to be 1 over 12. And root 18. Well, root 18. Okay. Now, I would say normally that would be your final answer, but in this case it's not. Can anyone tell me why this is not my final answer? That's root 18. Okay? So the 1 over 12 simplified is the square root of 18. Can I break that down into, here's the way that we taught it on Thursday. Are there any magic numbers in 18? And so I'm going to write my magic numbers down the side here. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And 5 times 5 is 25. So root 18 would fit in right in there between 25 and 16. 18 divided by 16 doesn't work out nicely. 18 divided by 9, yes it does. Okay, so root 18 on the top is the same thing as 9 times what? Times 2. So the same thing as the square root of 9 times 2 is 18. On the bottom there's a 1 in front, and I have a 12. Now, how does 9 and 2 break down? Well, the magic numbers are magic, and so they go poof, and they jump out of the window and they change. That's why they're magic. They change into, the 9 disappears, and what does it turn into? A rabbit. A 3. Root 2 on the top. Right, so the 9 changed into a 3. There it is. The 2 is left behind because it's got no magic powers. Okay, and so 2 is left behind underneath the square root. Now, does 3 over 12 simplify? I don't know. 3 divided by 12. Math, enter. This is a little bit tricky. Oh, it does. Look at that. So on the top is 1/4. 1 over 4. On the top is 2. So your final answer is root 2 over 4. Let's actually find that. You don't have the sheet yet, but I'm going to give it to you here shortly. That was O. That was a tricky one. Right there. But our answer was root 2 over 4. Where's root 2 over 4? Root 2 over 4, right there. And. Okay. So that was a little bit trickier one because it combined what we're doing today, which is rationalizing the denominator, and simplifying. Now, this is a simple simplify. Hopefully you found that. But it has other numbers now because, do the roots separately from the regular numbers. The regular numbers, let the calculator figure that out. Math, enter. Because they are going to be fractions. And we started with fractions with this class way back in September. But let your calculator do the fraction hard part. You still have to do, the calculator will not do square roots for you. Okay? So same thing, the calculator will not do algebra for you. And the roots and algebra, as I mentioned last Thursday, are very, very similar in the rules. You do numbers with numbers, letters with letters, or in this case, numbers with numbers, roots with roots. But then there's a few magic numbers here where you have to simplify the roots. It's a little bit more complicated that way. Whereas algebra, you just solve for x. Okay, so it's we're combining a couple things like that. Any questions on that? Do you want me to go over one more example? Or are you good? You just want to try it on your own?